Hello and welcome to chapter 5 of lecture 5 of philosophy of science, which is also the final lecture of IDCE. Now it may happen that we will divide this lecture into two parts because it will basically talk about confirmation, but I will like to keep it short and simple. Now we will start with the understanding of confirmation, that what is confirmation. Confirmation, as you know, is one of the signature theories or one of the tenets of what or with whatever our understanding of science is. That what is science? So we always say that something which we can confirm, right? Which we can verify and so on. So loosely speaking, roughly speaking, it is also close to the understanding of validation. It is also close to the understanding of verification, but it is also something which is more than that. Or how we will differentiate between confirmation and say verification. Confirmation, loosely speaking, is more like an idea that it is re-verification, right? So sometimes it is called as ramification, sometimes it is called as that we call it like it has been reproved, or it has been confirmed, it has been reasserted, some understanding like that. So confirmation, strictly speaking, if we can make a structure of it, so it will be like, suppose if there is a theory T1 and there is an observation T1, okay, and this observation is also verifying this theory or also confirming it, so it is a reaffirmation of this theory. So why I'm using this small t1, because it is having it is akin to, or it is one of the instances of this theory. Like suppose if I know that all x are y, suppose if this is a theory and I found a x which is also y, so it goes on to confirm this theory. So this is a very basic understanding of confirmation, and sciences do go on to confirm their theories, right? And the confirmation is a sure test that something is a science or something which is acceptable. Now, whether this confirmation which we understand in science is something which is also acceptable to us, or are there certain problems? There is a problem which we know, many of us know, which is also understood as the Raven's problem, right? Hempel, Gustavo Hempel, in the mid of the 20th century, actually exposed this thing, that the way we confirm with x dot y, x all x are y, we can also take an understanding of something which is neither x and neither y, also goes on to confirm all x are y. Now what I am talking about or something you will understand. Let us take the Raven's problem. What is basically the Raven's problem? Now Raven's problem, Raven, okay, many of you may not be knowing what is a raven, so allow me to tell you that raven looks like a crow, right? So usually if you have seen crows, they are black, ravens are also black. In India we see the crow normally like black, and then there is this part which is a little bit grey. In the ones which we talk as ravens, they are also in the same family, they are fully black. So those are called ravens, and usually if you see the size, so crows will be, I guess, so smaller, and ravens will be a little bit black, bigger, and definitely they are fully black. So we know, as per our observations has told us, that all ravens are black. So all ravens are black is something which we know. Now, if you know a understanding of it, uh, it is like for all x, if we symbolize it in logic. So it is like for all x, if x is a raven, then x is black, right? So this is basically the symbolization of it. And if you know logic a little bit more, you know that this is equivalent to, for all x, if x is not black, then x is not a raven. So we know that both these expressions are equivalent expressions, right? Sometimes some people use this symbol for all x, right? And people also use this symbol for implication. They also use negation like this, right? So these are also equivalent expressions. Now, till this place we know, because most of you who have studied logic will know that for all x, Rx implies Bx is equivalent to for all x, negation of Bx implies negation of Rx. And till now there is absolutely no problem, right? Now, how we confirm a theory? This is something which we need to understand. We confirm a theory by observing more instances of a theory and say that it also goes on to confirm that theory, right? So confirmation is basically a reassertion, right? So we are reasserting every now and then that something is right, or something, the observation which we have talked about, and something is a proper observation. Now, how this becomes a problem, because sometimes Raven's problem is also understood as paradox of Raven's problem, or paradox of Ravens, and so on. Now, if for all x, Rx implies Bx, or for all x, negation of Bx implies Rx, are equivalent expressions. So you might be knowing that, suppose if you observe a black raven, so you go on to confirm this theory, right? Because you know all ravens are black, or this is the theory which has been told to you, and this is a statement which has been given to you, and you want to confirm whether all ravens are black. You went outside, you found a raven and it is black, so it goes on to confirm this theory that yes, all ravens are black. Because many a times you have seen ravens and all those ravens have turned out to be black. So every instance, every observation of a raven is telling you that yes, it confirms this theory. Now if you come to this theory, if something, like for all x, if x is not black, then x is not raven. So something is not black, so I may take something is white. So if you see something which is white, and that white thing is a shoe, or the white thing is another bird, or the white thing is any damn thing on this earth which is white, what will happen? If you observe a white thing which is not raven, fine. I am saying it's a white thing because white is not black. You can also write it as, if you observe a non-black thing, right? So if you observe a non-black thing and also it is not a raven, so what you go on to confirm? I can write it here. If you observe a non-black thing, right? And it is not a raven as well. You again go on to confirm this theory that all ravens are black. So you understand the thing, what is happening. Irrespective of the fact, like this observation looks very, I will say, intuitive to our understanding, that I have I have been given this statement, all ravens are black, and I went out to confirm whether all ravens are black or not. I went out, I checked, and I found that whenever I saw ravens, irrespective of the fact that how many observations I have taken, and we have talked about inductive generalizations and so on, so you can connect those understandings as well. So whenever I see a raven, I have found that thing to be a black object as well. So I have confirmed all ravens are black. There is absolutely no problem. But whenever I have seen a non-black thing, and I also found that it is not a raven, I am again going on to confirm this theory. So what is happening is that the way through which we are confirming a theory does not take into account either ravens or black objects, and still it is going on to confirm that all ravens are black. This, roughly speaking, is understood as the Raven's problem, which was suggested by Hempel. There are a lot of solutions to it. There are also a lot of versions of it, and there are a lot of other things to it as well. Not solutions, proper solutions, rather than certain kind of ways through which you can actually tackle this problem in a better way. But irrespective of whatever the solutions have been provided, you can definitely read it on internet. You will also find a lot of material, and I will also supply those materials to you. Irrespective of whatever the solutions or whatever the addressal to this has been provided, it definitely talks about that confirmation is a problematic area in either, you can call it a problematic area in sciences, and definitely in the philosophy of science. We will, in the next part of the lecture, we will discuss another problem which is having a very clear understanding of confirmation, and it has some issues which will make you understand that even if we are educated, even if we have studied logic, even if we know what sciences does and how these things occur, we usually falter in decision making. So in the next part of this lecture, we will be discussing what is called as Basin selection task experiment. Hello and welcome to the second part of the lecture, where we will be discussing the Basin selection task experiment. Now, this selection task experiment tells that even if people are informed or people are educated, they sometimes usually make some wrong choices. And this is the interesting part of this experiment. Like, there can be, again, a lot of versions of Basin selection task experiment, and you will find it in different books in a different way. But in the core, it remains the same. Like, suppose if I need to confirm a theory, I will remove the Basin selection task experiment from here, and I will put the statement, a statement which you need to confirm. A statement says that if there is an even number on one side of a card, then the other side of the card is red. Fine. So it's a simple statement which has been given to you, and you need to confirm this statement. What is it? The statement says that if there is an even number, any even number, on one side of the card, like suppose we have a card in one side of the card there is a number and that is an even number, then the other side of the card has to be read. So in one side there will be a number which will be written, and the other side will be a colored because these are colored cards. So like suppose if we are given options like this, that this is the first card, I call it card A, and here 2 is written. Fine. Okay. Now there is another card which is card B, where say 5 is written. Then there is another card and this has been toppled. We do not know what is the number which is written, but we can see the color of the card, and the color of the card is red. Fine. So let us name it as card C. And there is another card. This is card D. The color of this card is green. Fine. So we are provided with 4 cards. The first card, you can see the number, that is 2. In the second card, you can see a number, that is 5. In card C, you will see that you cannot see the number because it has been toppled, it has been put on the other side, and you can see the color of the card. Here you cannot see the color of the card, right? Because you do not know what is the color of the card. It is on the other side. On this also you cannot see the color of the card. Here you cannot see the number of the card. So it is red in color and this is green in color. Now the question is that if you need to confirm that this statement, if there is an even number on one side of a card, then the other side of the card is red. So you need to confirm this theory. So the Basin selection task experiment says that again there are a lot of versions, that which cards you need to say remove or check the other side so that you can confirm this statement, right? So sometimes it is also said that which how many cards you need to flip-flop and see that whether you can confirm the theory, and how to confirm the theory. Which cards, how many cards do you require? You require 4 cards to check, you require 3 cards, you require 2 cards, or you require just 1 card. Then some theories will, the other way of questioning will be that which are those cards which you will remove, right? The other way of questioning can be that how many cards you should not remove, and so on. But given all these understandings, let us try with a very basic understanding that which cards you need to check the other side so that you can confirm this theory. So what is going to be your answer? So I request all of you that if you have not gone through this test before, and if you have not seen this test before, so I request you to pause the video and check for yourself that which cards you will like to remove in order to check whether this statement is a true statement, or whether you can, how to confirm this statement using removing the sides of the cards. So you can stop the video and check for yourself. Okay, I hope that you may have stopped the video and checked it for yourself. Now let us come to the analysis of it, that how we need to go for it. Now when this experiment was conducted, and it was conducted even on very educated people as well, the answer was not found satisfactory, right? Now I do not know what your answer is, but if your options are like, the first option says that you need to check A and C. This is the first option. The second option says you need to check A, B and C. The third says that you need to check A, B, C and D. Fine. The fourth option says that you need to check A and D. The fifth option says you need to check B and C. Okay, and maybe we can take another option. Sixth option says that you need to check B and D. Fine. So if we take all these options, that which of these you need to check in order to see that what is going to be your answer. So this understanding or this question was put up to a lot of people, and many of them were very well educated and they were expected to perform these tasks properly. But what was the result? Now, most of the options, I do not know what your answer is, you can check with this, said that the first option is the right option, right? Most of the people clicked that you need to check this card and also you need to check this card, because this is 2 is an even number and here it is red. So if you move this card and check whether there is the red color or not, so you confirm the theory. And similarly, if you remove and say topple this card and say move this, flip this card, so you will check that whether there is an even number. It can be 2, it can be any even number, right? So this will also go on to confirm your theory. But sadly, this is not the answer. The answer to this question or this task is basically, have I put the answer as well? Yes, the answer is D. That is A and D. Sorry, answer is the fourth option, that is A and D. Now, how and why it is the case? So, in order to understand this, I will remove these things, and I will also remove this statement. Since you know this statement and you also remember this statement, so I will remove this. I will keep the cards here and the options as well. And why the A and D is the answer is something which we should understand. Now, if you see this statement, or if you remember this statement is basically an implication. An implication where says that if there is an even number, if I represent it as P, then the card has to be red in color. So I can also use this rather than P, I will call it an even number. So even number implies that the color of the card will be red. So we know this. Now we know this implication, and all of us have studied logic, right? And we know the fallacy of affirming the consequent as well as denying the antecedent. We also know what is modus ponens and modus tollens, right? Now, if you see from this, there are two ways in which you can conclude. If you get E, then you can conclude R. And if you have E implies R, you have negation of R, you can conclude negation of E. Right? Okay. Now, this is the logical way of studying this. So, if I am giving you an implication which says that if there is an even card, then the color of the card is red. So how you will confirm it? If there is an even card, the A, then it is red. And if you take this card and flip it and you find that it is red, so your theory is confirmed. There is absolutely no doubt about it. And it is the right answer which most people have opted for. There was absolutely no problem with this understanding, right? But the problem was here and the problem was here. Many or nobody was also interested in this option B. So this has been well taken by most of the people. This was not opted by people, so I remove this. Most of the people opted for C option and very few people opted for D option. And here the problem was there, that since most of the people are opting for C and it is not the right option, why it is taking place? Because we understand implications usually as equivalences. This is one way of analyzing it, that human beings always think that an implication is usually an equivalence. Though implication is unidirectional, however, an equivalence is bidirectional, right? That whenever we say that P is equivalent to Q, it also means that Q is equivalent to P. But when we say P implies Q, it never says that Q implies P. It only says negation of Q implies negation of P, right? Because of which this is modus tollens and this is modus ponens, right? And this is a valid argument form, which we know. This is also a valid argument form. So in order to confirm, what will happen? Like suppose there is a red card, and the other side is not an even number, suppose. Does it go on to confirm the theory? No. Does it go on to say refute the theory? No. Absolutely no, because we know that if there is an even number, so like there is an even number on this side, then it has to be red. So if it never says that if there is red color, if a red color card is there, it has to be an even number. But we usually understand it in this fashion, that if the implication goes like this, the implication should also come like this, which is not the case. It is an equivalence. If it is bidirectional, then it is going to be an equivalence. So this is not the case. So irrespective of the fact that you flip this card and you check the other side and you found an odd number, you found a decimal, you found a fraction, does not matter. It is not going to have any impact on the theory. However, if you flip this, I remove this because it is not of any use. If I find that I flipped the green card and I found an even number, suppose. So what will happen? That I found a non-red card, that is green one. It can be any color, blue, black, whatever. Now I found a green card, I flipped it. Once I flipped it, I found that there is an even number. Now this goes on to refute the theory, because then it should not be an even number. In this case, if I flip this and I find a fraction, it confirms the theory. And a few minutes back we also talked about that if all ravens are black, I find a raven and it is black, so it confirms the theory. Or I find an object which is not black and it is not a raven, it also confirms the theory. And this is that understanding, that if this is green, and since it is green, therefore it is not red, then the other side of the card should also not have an even number. So it can have an odd number, it can have a fraction, it can have a decimal, whatever, whichever is not an even number is something which is possible on that side. But if I flip this and I find an even number, then my statement will be not confirmed, or in fact it will be refuted. It will say that look, we have found an instance which is against the notion of what has been given in the statement, that if there is an even number, then the color of the card is red. So this understanding is something which does not come naturally, right? And this is the problem, that logic is not very natural, and sciences which is based on logic usually employs logic. But then even if you are employing logic and we are confirming with the help of logic, so you find that there is a non-black object which also confirms the theory that all ravens are black. Or you go for the selection task experiment, you will find that people who are confirming, even if they are educated, are using. And allow me to tell you this, many scientists, I'm not questioning their abilities or something, many a times in a subtle fashion do not understand these things, or they fail to comprehend, and their line of argumentation or their line of say hypothesizing a theory or confirming a theory actually are fallacious. So it can be the fallacy of affirming the consequent, or it can be the fallacy of denying the antecedent, and those create problems for validation, those creates problem for confirmation and science itself. So, since it is an introductory course on the philosophy of science, I am not taking the nitty-gritties or the complexities of all these things, but we should very clearly understand that say from a very layman's point of view, that confirmation in itself poses a lot of problems, and it is a very difficult and intricate issue which usually people will find difficult to comprehend, understand, as well as apply. Therefore, in the later part of this course, we will also understand why it is called confirmation is a myth, right? So, thank you very much for attending the lecture on these parts. I tried to finish the IDCE in 3 lectures, and if there are more doubts or if there are certain other issues, so we will be taking it in another lecture. So thanks.